Why is my thing not running? Why is my thing not like? Oh, this is like a. This is my default setting is to high. Sorry, by the way, high. My default setting is to always want that thing running. I've got like some weird background image running. I'm assuming this machine restarted because of reasons. Probably Windows update or something along those lines. So, hello everyone. How are you doing? It's good seeing you again. Um, this week we are going to look at code review and refactoring. So let's get a holistic view of this thing. We've got I barely looked at it, it already looks wrong. um, so if you just look over here, we've got the CPP file, which has just a literal ton of stuff. But all this this is just a method of dealing with GUI. This is how you get GUI up and running. I'm not too worried about how getting GUI up and running. This is more windowing. So whatever you need to do to speak to Windows to get it to like display a window for you, whatever you need here to like get a paint loop or a redraw loop up and running, that's all here. Whatever you need to do to capture mouse input, that's all in here. Whatever you need to do to say, hey, you know, I'd like this window to be this size, or I'd like this to be painted, or the background to not be erased, or the window should close when you close, it's all in here. There's an about dialogue in here for some reason, which I don't know if we're gonna really stick to the about dialogue. I'm not really a fan of this kind of dialogue system, and I can't think of any kind of setting that we'd have in the game that would require something like this. So you know, we'll we'll think about this at some point. I'll just think about it in the background. But my bigger question here is, where's the implementation of this thing, of this like this game thing, right? So if you start doing a code review, you look at like, okay, here's a folder structure. It's got header files. It's just a bunch of header files thrown in. I see things like the platform header files that we require to get stuff running on Windows. This defines resource identifiers for like little dialog icons and strings that are declared in the RC file, the resource file. This is actually generated by Visual Studio. So this and this are generated by Visual Studio. So whenever this thing builds, it just does whatever, right? And there's the resource files. These are icons, resource definition files, and more icons. So those are fine. These default filters are fine. These things here are these yellow little block things with the sub things. These are called filters. You could have a flat file structure, and then you could just throw everything in the same folder in on your file system, on your like on the root of your hard drive, and then define your project and create a bunch of filters, and then drag files manually into these filters that you create here. But that's not a nice way of organizing it. You need to keep things decluttered. You need to organize them into files correctly. So yeah, it's just a bunch of external dependencies. I don't like that at all. I don't like depending on external header files. And if I were like references, this can't be. I think I just broke my ID. Anyways, I don't like all these external header files. It adds unnecessary bloat. Oh, kind of. The compiler is smart enough to not compile stuff it doesn't need. Like things get stripped out at some point that aren't really needed, but I don't like all these extra things. So let's start in here. What does this thing have? This thing has the resource file, and the resource file uses target var. So you've got framework.h. Framework is target var, lean and mean, windows.h, and then a bunch of common header files, right? Runtime library files, std, malloc, memory, teacher. Okay, this is boilerplate. This is all like required common things. So this is fine. So you got this thing, and then you've got the CPP blocks, which is the project name file. So I'm assuming the whatever it is here that we're doing sits here. So MPS, what is MPS? Game simulation MPS equals new game simulation ghwind set timer ghwind uint pointer MPS timer proc on timer. On timer is declared here. and here we go. See, that's the definition. The implementation of it is you could cast out that simulation pointer, you get the client rate, you grab a DC, and you tell this MPS. Why is it called MPS? Like my battle simulator? Like, what does MPS mean? Like, it doesn't actually mean anything. It would be nice if there was a comment somewhere that said MPS means. Okay, that's the first thing. I don't like these variable names that don't mean anything. Right. 16 milliseconds does aim for 60 FPS, so there we go, that's correct. Delete, kill timer with simulation, and then delete simulation. Okay, great. So now we've got simulation, delete simulation. Yeah, again, I just want to simulation update and draw. Update and draw is such a nice function name. Why couldn't all functions just be so clear and succinct? You're updating and then you're drawing. So whatever. You pass a rectangle in, you pass the HDC in, and you pass in the mouse. So I'm assuming that the mouse is our way of saying something was clicked, great. Something was moved, great. All button up. So if you put the left button down, it doesn't mean anything. The moment you let go, it counts a click. I'm not convinced that is the best way to handle it. Oh. Yes, I've got bits of metal laying at my feet. The place here is a little bit of a mess. I'll do some cleanup. I'm just thinking, like, do we count click or do we count mouse first, mouse move, L button down, up, double click, L button down, up, double click, down, up, double click. There is no such thing as a mouse click. You have to either say that I will make a mouse click. I can understand double clicks. It makes sense to do double clicks, but I want to not have double clicks. So let's just say if you put the mouse down, let go of it, that counts as a click because it makes that clicky sound. Right? It's like creates a click. Not happy with it. I'd like to say if you put the mouse button down and then not move the mouse away and then let go within a certain time, that's a click. But then you have to go and get that get system metrics thing and then go find the metric for it. We'll do the simple way for now. I might not be happy with that in like 35 seconds, but we'll see. Okay, so you've got some mouse movement and you've got a way to pass into the simulation. Here's the thing happening. So inside here you've got the cpp blocks.h and cpp blocks.h immediately. Okay, resource.h makes sense. Even though I'm convinced I've hash included resource. No, I didn't. That's not good. And collisions.hpp. HPP header with a partial implementation. That's kind of what that's supposed to mean. That's what it means in my brain. Let's just check what that does. Oh, there's a bunch of stuff happening here. Okay, so I'm not happy with how this works. So this was supposed to be like a weird singleton thing with like a ECS kind of thing tied to it that gives you this collidable thing that you can with which you can do stuff. I don't necessarily like this implementation. I feel like it's prone to error. It is a partial ECS, but I've mixed the E and the C kind of together for no reason. Again, I do apologize. I was coding in a hurry. It was like I was super excited. I think it was like 8 o'clock or past 8, and the baby was about to go down for her final sleep, and I kind of just wanted to power through the video um, before I'm sitting like 2 meters away speaking loudly and waking her. So I do apologize. When you code in a hurry, you code weird things. This does not look right. None of this looks right. So let's go to the drawing board. Let's grab paint. Let's see what we can do. So we had a I don't want. I'll just do, yeah, this is fine. So I want to be able to say there's a, let's do this. Here's a component. Well, entity and component are kind of interchangeable. What I want is here you declare here's a collidable thing. It can collide with other stuff. When you declare this collidable thing, you don't have to manage it. You just say I want a new instance of this thing, and then you place it on the wherever, and then things must just kind of happen, right? That's what I want. And I mean, this is interesting because I suppose this brings up a question that I've always asked myself, and I've always been asked. When you're working on a personal project, how far do you how formally do you approach the code? Like how complex do you want it? How formal and rigid and strict do you want your code to be? And my answer to this always has been, it's up to you. It's like how tied to that project are you? How invested are you in that code base? And I think the longer I carry on doing like little projects and things, the more I kind of just get the idea that it doesn't actually matter. Like I started this project thinking, oh, I'll be done in like maybe 2-3 hours. I'm on hour 4.5 now, and it's still not done. So I've now invested 4 of my off days worth of time into it, right? Or 4 of my free time hours into it already. So if I'm going to continue investing time and code into this thing, then even though I'm literally just going to complete it for the sake of my viewers and as a reference repository for people to look at, I don't want to put the repository out there and say, hey, everyone, look at this. If it's gonna look like garbage on the inside, right? It's like I don't want that. That's asinine. It's not the correct word. Asinine isn't the word, but to me it feels asinine to go out and say, hey, learn from this, and it looks like this. So I want this to be composable. I want it to be reusable. I want people to be able to look and say, this is a clever way of doing it, but I'll use this as an example and then I'll do my own thing. I don't want people to just kind of learn the bad habits. So in order for me to not teach the bad habits, I need to kind of not have the bad habits. So let's do it the right way. Let's define. I want this thing of which I can have multiple, and I don't want the cognitive load to be with the next guy, even though the next guy is going to be me at the next video. The idea would be that when you create this thing, it just that's magic. It just takes care of itself, right? So you just create these things, and they kind of just go live in the scene or on the stage somewhere, and that's it. They partake of the collision system by default because they are collision objects. There's several ways to do it. I can only think of one reasonable way that kind of hides the complexity from the end user, because when you define something like this, you're defining an API, and that API is it's facing you in your other classes that you're about to write. So when you use the API, it doesn't need to be intuitive, it just needs to be reasonable. It doesn't need to be amazing, it just needs to be reasonable. It needs to be good enough. And because I don't have super high standards when I'm writing my own code, when I am on the clock and I do code reviews for for the company that employs me, for my employer, I am super strict. I have a literal, there's a guidebook I have here with me with like all the different, what is this? If I can just flip, there's like a bunch of notes in here, there's like a bunch of stuff here that's like, watch out for these things during the reviews because of the way the internal systems work. We can't just declare stuff all willy-nilly. We can't allocate too much memory because it's a cloud-based solution we're building. So there's like a whole lot of like, complicated things I need to worry about. And on the far end of the scale, there's the front-end solution which runs on mobile devices all the way up to desktop devices. And then there's the cloud sector, the cloud solution, the stack, and those microservices that also need to be scalable and performant. So there's like a lot of things you have to think about. So I just got my little notebook. So I was looking at this code base the other day. I was thinking like, why don't I apply this to my own code? Like, why am I putting something that's poorly crafted in the world? And that's something I apologize for. So let's fix this. The first thing I would like is to just I would just like to say I'm going to start with the end product, right? I want this thing to say I want this brick thing and it is collidable, right? Yes, but this thing doesn't need to kind of live here. It can live anywhere, right? So why is this filter just like sitting there? Like what does this look like? I said that's let me just see. This is the tutorials, the repos, how to coding, that one repo. There's a pigeon walking over there. C++ plus or is it CPP? Sorry, let me just a little bit of off-cam action here. Okay, and here is the just everything just thrown there. So I want a folder called collisions. I think that's how I spell it. Collisions. I don't care if it's actually how I spell it. And then I want another folder called it's gonna be game entities, so let's just call this entities, right? So now anything in the collisions folder sits in the collisions namespace, right? So let's just put that there. Boom. Collision sits in the collisions namespace, and then entities will have a thing like a ball, a player, and etc. Right? So the holy grail. Should this all be lowercase? No, it should not be lowercase. So ball. It'll just be the header file with the implementation. It doesn't need to be that fancy. It just needs to be enough. So you got the ball. You don't call this thing the play. You call it a paddle, right? So you've got the ball object, the paddle object, and then you've got a brick object, right? So I'm just like making sure that everything is understandable. If someone looks at this thing at a glance, right? And they're trying to find out, oh, like where did this guy define those little thing that bounces around the screen, right? That ball. Right? Where's the ball? There is no such source file. Why is there no such source file? And why is it sitting in collisions? It's actually an entity. It's a game object, right? So it should be in the entities folder, in the objects folder, right? So yeah, let's just think about it from a third-person perspective. So you got the ball, you got the brick, you got the paddle. The brick is the little stack of bricks thing. Then you've got the bounds. So the bounds are just a wall, right? I think one of the interesting things that we actually managed to do is that the interface here is nice enough, but I don't like that you have to pass this collision checker into it, right? I don't like that at all. I want this to just be a collidable and that's it. There needs to be some other way that you collidable manages to get hold of its collision checker. So the first thing I want to do is I just want to like fix this weird interface. So collidable is part of a collision system, so anything that's collidable is just collidable, right? So collidable has no concept of this collision manager. It shouldn't, right? The further down you go into the code base, the less of the internals should be exposed, right? Why would you need to now go and find this collision checker thing and create one or find one? How would you know there's a single instance of it if it's being exposed? So now you say, oh, if you look at this code base and you look at this interface for this class, and you say, oh, here's a wall. A wall is a collidable. Yeah, you can collide with a wall. So it needs a collision response because of this. This thing has pure virtual functions in it. Game collidable? That's not right. This should be collisions collidable. Ah, see, it's not in the right namespace. So yeah, let's just fix all this. So the first thing we need to do is we need to go and we need to define a new filter. So the filters would be collisions and entities. So we'll just map the filters up straight one to one with the folder structure here. So let's just define a new filter. So you do add new filter entities. Great. Inside entities you add existing items, and then just go find these things inside your entities and say yep, add all of those. Boom, done. That was a great video. Thank you guys. No, I'm kidding. Let's find these entities, and this entity ball, this ball entity will take whatever was here in ball, right? Boom. And this becomes interesting because what namespace is the ball in? Is it in a namespace? Do you care about that? No. Right? Oh, what was that? I hit the wrong button. Hash pragma once, right? So it's okay there, done. Ball collidable. So obviously you have to hash include. I think you do collisions collidable. Let's just do collisions.hpp. Right? There'll just be one header file that you include that'll just have all the interfaces in it. So boom, there. So this is interesting. Ball is public collisions collidable. I want that namespace to be collisions, right? So let's just, why not just grab it out of here? Collisions, and now you've got this thing namespace collidable. Boom. So now ball should make sense. Come on, ball, makes sense. Must be a class on a public collisions collidable. That should work. Collisions. Oh, yeah, collisions collidable. There. Is IntelliSense just having a flip and laugh? Let's just leave IntelliSense. I think IntelliSense is just having a laugh. I'll rescan the solution now. Let's just power through. So, virtual collisions, collision type, get type, return collisions ball. It should say collisions collision type ball, but collisions ball is fine. The compiler compiler goes in and sees all these things that are in this namespace. It exposes those types automatically. You don't have to stress about it. So there, collisions collidable. So there is this namespace, collisions, and there's this class inside of it. Oh, I know what's wrong. Collisions actually moved. New add new filter. Sorry, I don't use filters so much. Collisions, I think it was collisions. Let's just drag that in there. Yes, replace the file in the destination. Right, so this thing actually just remove this. Yeah, remove, and then just add it again. Add existing item, collisions. I might change the folder case. I don't care about the folder case. I like the filter case because this is what I stay at all the time, but I might change the folder case just for consistency so that it kind of matches almost one to one with what's on disk. So now we go. Here you've got a ball, it's a collisions collidable, and the ball is happy. So you've got a brick. Let's just go to ball, grab some of the boilerplate stuff off of ball, and then just grab ball out of collisions.hpp. So there is a definition for a ball there somewhere. There's a wall. Huh. Was there no definition for the ball? See, sloppy. I do apologize. Oh, there's the ball. Oh, brick. So, I've confused myself. I've unconfused myself. Okay, great. So you got ball. Let's just do public collisions collidable, and then we'll fiddle with the collision types. So you got brick, public collisions collidable. Brick is a public collisions collidable. Get collision response returns that, and it returns collisions break. Great. So I'm not too happy about this like get type. I'll think about this get type a little bit more, but for now I'm kind of okay with having ball and brick kind of work this way. So in collisions, you've got a ball brick, you've got paddle. Let's just grab this boilerplate, because this is always going to be the issue when you do refactors. You might end up with like a whole lot of header files. I would rather have more header files than more like thinking complexity. Like, it's just my personal opinion is, my personal preference is, I would like more like fine-grained a file system. I'd like the file system to have a more fine-grained feel to it versus having to have more fine-grained thinking when looking at this massive header file. Like, look at this collisions. It's just this huge header file that's got everything in it. It's just, that's not right. And well, I think us as developers, we need to be really careful about things like this. You need to be really pedantic with yourself, even though you don't have time, and it's like, you could have done it in like 13 seconds if you just done it the easy way. Is it really the easy way? Or look at this, right? Here's a classic example. Like, do as I say, not as I do. I could have done this like on day one. Sorry, just wanna. I could have done this on day one, and it would have been easier. Like, it would have been, well, not easier, but it would have been a little bit easier to just define the interface correctly. Now, instead of doing that, I'm now fixing this interface after however much time, and that's not correct. This is time that's now essentially wasted, even though it's like, yes, it teaches you a valuable lesson about what not to do. It still feels like time that's wasted, because I could have been moving forward with the code. Instead, now I'm moving kind of backwards. But I digress. I don't specifically need to. I didn't need to do this. Again, I'm not going to use this repository again, but other people are going to use it, and other people are going to have to kind of struggle with, like, why is this weird? Where do things? How did this, like, how to coding guy, not how to coding this correctly, right? It doesn't make sense. So okay, so now collisions. Everyone includes this collisions thing and this collidable thing. There's so much cognitive load here, but luckily, because we're doing this now, you say I got a new ball, and the ball, I kind of want that to be no, we're gonna build the game rules, and I'm just thinking I kind of want it to be something else, but this is the concrete end of the. There's the sliding. Let's just go to my trusty illustration pad. There's this. How do I define the scale now? There's like this sliding scale of. No, I have to click off it. Yeah, it has to be this first. Let's pretend this is like 3. This is the worst color to try and display on screen. I apologize to all of you who are like in the middle of the night watching this. I've now woken you up with like this bright yellow on white thing that's giving you a headache. But just bear with me. There's this sliding scale of, this is abstract, right? You need to think really hard about the abstract of it, because this is what you expose as the implementation to other end users are going to inherit this abstract thing. They're going to be forced to implement these abstract or pure virtual functions, right? So you got an abstract class or an interface, and you have to now, you're forcing them to, you can't be one of these unless you have these functions inside that you've defined, and those functions have rules by which they work, because the rules are based on the code you've written or the interface you've exposed, blah blah blah. Then you hit these things where you say, okay, well, I've provided a default implementation, this is but it's virtual, so you're free to override this further down the line. You can then call, if you override this function, you can still call the base class implementation, because it's not a pure override. It's not like you've just said, here's this new function, it's virtual, so you can use it, you still have access to the base implementation. Then you've got the concrete thing, which is way down in your derived class. You say, you know, I'm public this, I extend that like way up there class, and here is my implementation of this thing. So what I've done now is I've said, well, here's this pure virtual set of functions, and then here you are now forced to implement those functions. So I kind of just did that, right? I cut out this middleman thing. I said, you know, forget all this noise. Make the interface pure virtual, so you're forced to implement this. The collision manager thing takes care of whatever it needs to do, and then tells you, hey, listen, you've hit something of this type, do your magic, right? I don't like the concept that you need to kind of tell this thing, like, oh, what is your type? I don't like this get type function, if I put it that way. So what I would like is, I want to change that. I want to remove the weight of this. I don't want to what have I done? I don't want to stack a bunch of pure virtual stuff that you need to implement. I want it to be a nice clean one-to-one implementation. So if you inherit from this thing, you implement this one function and then you're done with it, right? So how can we do that? Let's see. I think one of the first things we can do is, let's just look at this collision header file. Let's see, we've cleaned up a bit. I want a collidable to not take an instance of this collision manager. Why doesn't collidable just take this collision type thing, right? And then it just has a member that's a collision type. So this collidable thing will have a collision type, right? And then when you declare this thing, you tell it, hey, by the way, my type is this, right? And that's it. So now there will be some way of doing that, but what this does is it removes the need for you to have to implement this. This just simplifies it a lot. So let's fix that. So you don't need that. You just say type and type. Or even better, because this thing is a friend of the, oh, it's not a, oh, it is a friend. You can now make this get type function, because I don't like exposing this. I don't like that being non-const. Let's just yeah, this thing. It doesn't need to be virtual. It can just be a function, right? So what you can do is say you don't want that to be mutable from friend classes, because friend classes now have access to it. If you don't want that to be mutable, you can just make that private. So this type is immutable. Once it's set, it remains const. Oh shoot, what have I done? Once it's set, it remains const, but obviously you can't say const. I don't want to fiddle with const cast right now, so we say type. We've got this collision response function that you're now forced to override because you care about something happening to you. And in this get type, it just returns type, right? So you just do return type there, and it's no longer virtual. We should say final, but I don't think final works in this language. Again, apologies. I do like several things in other languages, but I kind of feel like final is the correct terminology. I must just check what final means. I know Java has final in it. In which case it actually means this is final. You can't derive further than this, right? I don't know what C++ has for that. I think you can just make it protected, and that's the end of it. So when you do a public inheritance like this, you now no longer need to this and this says, hey, listen, there's no such thing. I'm not overriding this. This thing is inaccessible, right? So what I want then is when you create this thing, you say, hey, this is a ball. Just, by the way, I'm a ball. And that's it. How clean is that interface? Right? This is what I want it to be, a neat interface. So now ball only cares that, hey, I'm a collidable, my type is ball, done. Here's this collision response thing that I deal with. The rest of it is you deal with like whatever code ball does, it does its own thing, right? But now that's all you care about. Like ball just does ball gonna ball, right? So this is kind of what I wanted. I know we are like wasting time refactoring. Why waste time refactoring? But the thing is, If it was just for me and I wasn't trying to like share it with people, I would write it as garbage as I want, because I got only like 20 minutes every once in a while to actually fiddle with code. But you know, I'd like to present this and say, hey, you know, like, look at what I do. Um, okay, so we've dealt with ball. So let's just fix brick. Uh, and now we no longer need this extra bit of interface. Oh, this is so nice. You say, hey, this is a brick, done. So you can create this collidable of some like concrete type. You inherit this this interface, so you inherit this base class, and you say, hey, I'm going to do something. This is my collision response. When things hit me, I do something. I respond in this way. This is why we don't pass a pointer to the other objects. Each object will be notified, hey, you hit a this, and hey, you hit a that, and that's it. That's all we need to care about. So this is nice. So paddle, let's just finish off paddle. Like physically, if you go and run the code and you look at it, it should still do the same thing. It's like nothing moves and nothing does anything. But if you go into the code base and you try and add a piece, it's going to be incredibly easy, because you say, hey, there's this new collision type, and then no one cares what the collision types are. But when they hit each other, they now know, like, hey, when the wall hits another type, wall knows what happens to wall when what happens to wall when things hit it? Nothing, right? So that's nice. What happens to ball when ball hits something? Ball bounces or does whatever. So that's nice. There should be another hook into the collision system. Oh, why does this not look the same? That. so now when you create these things, so now paddle also has its own. So now when you hit these things, when you create these things, and you say, you know, my simulation has a wall and a ball and a brick and a whatever in it, it all makes sense. It's not this like weird mishmash kind of thing where everything just sits in the same header file. So now the hard part here is, how do I hide the implementation of the collision system in such a way that, like, there should be like this function, like this now is kind of a the header file defines, yes, this implementation. So what I want for the header file is, it needs to define this implementation, but this should go into a CPP file, right? Because there is now some kind of implementation in this thing that needs to know something that I don't want to expose in the header file. This collision checker, does this actually exist? Does it do something? Does collision checker do something? No. Yeah. So then there's no reason for this thing to exist, right? There's just this collision checker class that is a friend of this thing that can access these protected members, and that's it. This collided function shouldn't sit here. It should be in an implementation file. This collision response should sit here. It should be public. It should be inheritable. That when you inherit this from this class, you now have these public attributes that you can access and do things to. You need to obviously affect X and Y with the knight to move this thing around and do whatever, but that's publicly accessible. You can set the DX and the DY and things happen. And then you've got a collision response, right? So this, there should only be one collision checker. There should be one instance of this class. So why is this here? Oh, because this has a list of pointed to collidable. Yeah, we've hit like this weird problem with, like, there should be so let me just think about it. There should be, this thing shouldn't be in the same header file, right? So this thing here, this collidable thing, should be in the collisions header file, right? But then this implementation here, this collision checker thing, should kind of sit on its own. It shouldn't exist there, it should sit on its own, and we'll instantiate that thing somewhere and it will do something. So let's kind of just fix this weirdness here. So this collidable can't take this header file because all it knows is there is this thing, it's a class, it's with this name, this keyword is reserved, and it is a friend of this class. So it doesn't need to understand the definition here in this file. It just needs to for declare and say, hey, here's this thing, right? So why is this for declared? I don't think it needs to be for declared in its own header file because this is inside the class body, so that should be fine. And obviously collision checker is now throwing a fit because this is not overriding anything, right? That's the reason it's throwing a fit. It's still in the same compilation unit. It should be able to see things defined above it. It's just throwing a fit because it's now not overriding anything. So this is perfect. We're simplifying this thing. We're saying, hey, there's this one concrete instance, and I want that concrete instance to live inside this collisions folder, but I now want this to be a collision checker. It should just be a CPP file. Yes, I'll explain it now. This collision checker, I want to define and implement straight in a CPP. Oh yeah, let's do it the right way. So if I want to include collision checker somewhere, new text document. Let's not do weird things, right? So this is just a plain old simple boarding header file. Yes. Plain old simple boarding header file. Let's just add it to the collisions, add existing item. You can select all of these. Visual Studio is smart enough to filter out what it already knows it has. It doesn't like struggle with whatever you're doing. So here is this class collision checker. Oh my word, is that the whole class? Boom. Now there's this thing, a collision checker, and this thing only knows there's this for declaration, this type, which is a friend of this. I don't think it needs to care. This is this is checked at some other point when you compile. I don't think it's going to throw an error like now. There's now this header file. You do pragma once. So now I need a vector. Am I using vector for anything? Nope. Vector can come out of this file. It's one less weird include in the wrong place. So yeah, I'm using a std vector of this collidable star. Now this collidable thing, this collision thing, right, it just for declares this thing, so you don't need that. And this implementation goes somewhere else. It goes somewhere totally different. So this is perfect. So I'm going to write a CPP file for this. I just want to get the headers kind of in the right place. So I now need to hash include collisions HPP because that's where this definition sits. So now I need to be in the same namespace, else I can't see into that namespace. I can't partake of any of that saucy goodness. Namespace collision, right? Maybe it would help a lot if I could just spell this thing correctly. So now, a part of the same namespace, we can see the same things. We're in the same scope. So now this works fine. I can include this header file. I can now start doing things with these. But this is a header file. There's no reason for this to be like this, right? So this is a header file. Let me just fix this CPP file quickly. Let's say you can't. Well, you can say pragma once in a CPP file, but it doesn't mean anything. Let's just find collision checker. .h. It's not a partial implementation, it's a full implementation. So now the way this works is we care about these things, which they shouldn't have an implementation in the CPP file. In the header file, there shouldn't be an implementation body. This should just be the definition. This should just say, hey, here's this thing, right? It is a collision thing. So inside here, what we do is we say this is the class, that is the function, right? but we are missing the namespace, so we need to say collisions, collision checker, right? Collisions, collision checker. Isn't that how that works? I'm part of the class and part of the thing. Yeah, that's how that works. So again, collisions, collision checker, destructor, symbol, collision checker, and that's how that works. So this is how I now define here's my this thing that's part of this namespace. So this virtual void add collidable. I don't believe that should be virtual. I believe that should just be the concrete public implementation of it. That's it. This virtual void check collisions, I also don't believe that should be virtual. It should just be the public implementation of it. That's it. Then I got this thing collisions, entities I collided with entities. Is inaccessible. Okay. So there's now this thing that's inaccessible. We'll just check this. We have this add collidable. This is a CPP file, this is the H file. So now we fixed this add collidable partially. There should not be an implementation body here. This is the header file. We're cleaning up, right? There should not be an implementation body. Implementation body should live here. So you say again, void namespace collisions class collision checker : which is the scope operator. Boom. Add collidable entities pushback collidable. Right. There we go. So now that is nice and neat. This is just a thing that says yes, this function that takes a pointer to collidable. Happy times. We have this private. Is it private by default? I think it's private or protected by default. It's definitely not public by default. Structs are public by default. Classes are something else by default. I honestly think this is like protected by default. When you declare members, they're by default. If you don't declare here's an access specifier for a section of this code, so if you don't do this, the implicit scope or the implicit access rule of that section of implementation or section of whatever class body is protected. And I think protected is correct. I think protected is the default. If you do that, it's the same as just not doing it at all. Right? So let's just see. So you got add collidable, then you got this check collisions. Let's just copy this implementation. I don't foresee there being any issues, but let's just say copy this. So now you've got these two functions, add a collidable and check collisions, right? Boom. This is when you go look at documentation for something, right? When you go look at, like, here's the public interface for this thing, you go look at the header file quickly, like, oh yeah, here's a class. So just go, because you have to include this somewhere to be able to use it. You include this thing, like, yeah, fine, fair enough, it's a namespace. The class name is collision checker, and you add collidables and you check collisions. Done, right? Very nice and neat. So yeah, where you put the meat and the potatoes of the thing, you got to actually do all like the weird jumping through hoops and whatever. But the implementation here in this instance is kind of, it's not sealed. Someone can obviously edit this and say, you know, and override this, blah blah blah. They can inherit from this thing and just kind of like override this thing. But I want this to be like the final state of it. There is a way to say this is the final state of it, but I'm not gonna struggle with that right now. All I want is just to neaten it up a little bit, so that when I say, hey, you know, this is kind of the thing, then it is kind of the thing. So there, we can actually a little bit fewer lines of code. So the collision checker does nothing, takes no arguments, has no beef. So the constructor, destructor, they do nothing. Like realistically, they do nothing because you're sharing. I know you should do ref counted pointers, but you're sharing a pointer of something with the collision checker. The collision checker just says, hey, you know, do these things exist? No, do these things intersect each other? And if they do, something else will happen. But you need to now have, because this pointer is passed into this other subsystem from somewhere else, there's this implicit contract in the code that says, hey, this thing will be around for the lifetime of however many times you're going to call check collisions, right? And then we need to now implicitly also define a contract that says, hey, you know, when this thing is destroyed, we're not going to fiddle with this memory for you. You outside, you own that memory. You've passed a pointer to me. All I'll do is I'll go to the other end of that pointer and then interrogate that thing and say, hey, did you hit this other thing? and that's it. That's the entire thing, right? So ideally, if you were to use this for each stage, you would maybe create a collision checker and say, hey, here's all your collision entities, and the stage would play out, right? Because of the type of game this is, the stage would kind of play out, and then you would destroy the collision checker. You might not destroy the entities, you might reuse them, but you'd create a new collision checker and say, hey, add all these things in and into the collision checking. So that is how I envision this thing to be used. I kind of throw away. So I want to make sure that I don't do anything weird in the destructor. So you add the collidable, it just sits in this vector of these entity pointer things, right? And you now check collisions, and it does a bunch of stuff, right? Just a bunch of stuff. I don't even know. Like, it's just a bunch of stuff. Checks against other entities and blah blah blah. So the collision checker is sorted, kind of. We now need to go back to this thing and say, hey, here is this. Would it be possible this collisions header file shouldn't actually have anything in it? There shouldn't be this HPP file. If we're going like strictly by the book for the entry point into this collisions namespace, there shouldn't be an HPP file. Now I'll explain this carefully before we run out of time. Your entry point, if you look at the bigger frameworks like WX widgets or the Qt framework, or you look at things like MFC or whatever, even Windows, GDI, you just include windows.h and start using stuff for common control.h, commctrl.h, which is the common control library, and your header file for the library, and just sort of start using stuff, and you say, yeah, I got all these things. There's one thing in common. There's this one big header file that you include that kind of includes all these other little subsystems and whatever. But when you look at it, like cleanly look at it, the way they expose the interface to you, it's because some of the stuff is written in like these DLLs that are part of the operating system, or DLLs that are part of the WX widget system. Because of the way it's written, you expect kind of that the header file is just the bare bones definition that the implementation is hidden. If you want to package this up and say, hey, here's a library that does collision checks, you want to pass them a lib file, a DLL, and a header file, and that's kind of it, right? So what this should say, just after looking at it carefully, this should say collidable.h, and then we'll have a collidable.cpp, which has all this sneaky goodness in it, and that will be it, right? Then this will be clean and we can start using it. So the first thing we need to do is we need to rename this thing. That should not be an HPP file. It is the entry point into this collisions namespace. It should not be an HPP. So I'll just rename. This should be called collidable.h. That's what it should be called, right? And then there should obviously be a collidable.cpp. So let's just go add that in. Yeah, I want to change it. I definitely want to change. I didn't like to go all the way down and just stop now Windows. Add, no, not there. Collisions, add existing item. So we'll just fix this quickly. I don't think we'll make any kind of like tangible progress, but I am happy with just kind of having most of the progress in having a reasonable code base. So collidable, let's just, well, I got a copy of this in here, right? Yeah, so let's fix the header file. So you've got this class, this external thing, this collision checker. You've got a bunch of collision types. I don't like where this lives, but I'll kind of overlook it for now. You've got this public interface, and then you've got that, and I want to add something that I see wasn't added. I want to add a virtual destructor. So when things are destroyed, it goes all the way up the chain. If you've overridden this, it goes all that up the chain and tries to call this as well. Virtual void. This is pure virtual. You must provide an implementation of this when you inherit from this class, and then you've got a protected friend and a bool collided, right? Boom. And then you've got collision type, get type. I kinda always leave these get types here because this just returns this member. There is no tangible benefit to having to go and declare all of this wherever. And my company accepts this. This is like if you've got a accessor that purely exists to access one kind of member, then it's fine. I think this is one of the first time I use private with this thinking. We generally don't design with friends in mind. Coding is a solitary sport. No, I'm kidding. We usually don't do interfaces that rely on each other like this. This is a special system. Most interfaces we build like REST interfaces. You basically define your types on both ends, and you say, well, I'm passing one of these two, and you throw some JSON at it. So we don't generally do friends. We also don't code in this language at work, just by the way. It is beautiful Java and beautiful JavaScript and PHP and some Python. Anyways, let's see. So this now is namespace collisions. There's this thing called the collision checker somewhere. There's this collision type. This is collidable, and it has this interface of which only these things are public, and these are fine. You can access them and do what you want, and that's it. You just need to know I'm a collidable, and that's it, right? So we'll obviously get to the meat and potatoes of the whole I know I'm a collidable thing soon. Let's just grab these. Right, let's just fix this so it actually compiles again before I call it a day. So you got collisions, then you've got this collidable, and then you got collidable. Okay, so now here is the collision type should work. Why is it not working? So here you got this collision type thing is undefined. Collision must be class, and let's give it. Oh yeah, obviously it doesn't know what that thing is. You need to hash include collidable.h, and now things will start looking a lot better. The compiler now knows what I'm talking about. It's not treating me like a person who knows not what I'm doing. Then you've got the destructor. I'll just copy that. The destructor is this like very interesting special case because you need to do that, right? But, yeah, there we go. There's the destructor. It doesn't actually do anything special. It's passed a pointer around to itself. When this thing gets destroyed, the pointer becomes invalid. But how do you tell the collision manager like, hey, sorry, I need this to now kind of not be valid anymore? You could make this add collidable function return a value like a token, and then pass the token back and say remove collidable, or you could just say remove collidable this, and it will just dump it off its memory there. There are options. Sorry. there's options. I'd like to have a add collidable, remove collidable, and then just the destructor does like call man remove collidable this, right? That would be ideal. So let's just kind of leave this comment in here as a reminder to ourselves. Hey, we need to clean this memory up of the collision checker, because the checker might remember there's this thing that needs to do here that needs to happen. So we need to just kind of take this up with the collision checker. So we got that. I'm just going to delete them off here as I go along. So I know it's going to like moan about syntax or whatever, but let's just do that. That's pure virtual. We don't provide a body for it here. Oh, this is nice. Bool collisions collidable, collided. Right, so boom, there, done. And that kind of cleans that up. Oh, I see the collisions namespace has a comment at the end that actually points to game, right? Not collisions. I just always like put this in here, so if you're at the bottom of the file, you know what's here. It's like, oh yeah, it's this namespace. Okay, so now collidable has this, but now collidable cannot hit anything. And I just want to see, does anything else compile? Does this even make sense anymore? But CPP block says, hey, you know, I'd like to hash include. Oh yeah, I want a bunch of walls. I want a bunch of bricks. So ideally, what you would then have is you'd have like, hey, add collidable, collisions collidable. Right, I think that's how that works. Oh, so it. Choice. Oh, collidable. Boom, collidable. I think that's what it's called, collidable. Huh? And it's no longer a partial implementation; it's just data file. Boom. So now collidable. Collidable that and collision checker doesn't actually need this because the qualification of the scope of the function extends to the parameters. I believe that's how that works. Which obviously extends into the scope of the function. So if you now start using stuff in the same namespace, it'll just work. You don't have to prefix it with whatever namespace. Excuse me. So this is perfect. I'm happy with this. I do want to add that remove and then search and remove function. I can do that off screen. I'll flesh that out, but I just want to make sure that this all kind of still looks right. So CPP blocks just has nothing of value changed there. But now this is the question. Were we using the collision checker? I don't think we were using the collision checker for anything. I don't think we were using call checker. Control F, F3. Yeah, we were passing it into the things. We don't need to pass it into the things. I'll tell you why now. First, we need to hash include ball. It needs to be with living collisions. It's a backspin. Oh, it's no longer a collision entity, it's an entity, right? Ball. And there's going to be a ball, a brick, a wall, a player. Ball, brick, it'll be like a wall and a paddle. I think I called it paddle. Ball, brick, wall, paddle. So now this is all nice and neat, each one of each. Is the entities in like a special namespace? Are the entities in a special namespace? Collisions collidable. Not an HPP. Not a doctor. Collisions collidable. So let's just fix this thing again. Unfortunately, this is the life. I want to keep track of this thing manually. I'm not waste a little bit of time, but it helps reorganize my brain. I work visually. If I don't create a memory of refactoring this, it's just never going to sink in, sadly. So I now know that this is 100% correct because I've looked at it. I know that player is not correct. That should be paddle. See, what are these kids doing outside? There's kids in the street, and I think they clubbing. I don't know what they're clubbing something. And this shouldn't be player, this should be paddle. Yeah, see, we're finding errors like this by doing tiny little bit of cleanup and review, because now the file name matches the class name, matches the type name. I love this. Brick is brick. That's collidable, that's cool. And ball is collidable, that's cool. So now the only thing that's wrong is collidable as a collision type. Not there. Collidable as the correct header file. Collidable as a collision type, that is not correct. This is paddle. So wall, paddle, brick. Wall, paddle, ball, brick. Yeah. I should reorder those to be alphabetic order. So you got B A B R P something and then W, right? And then ball should obviously equal 0. That's the beginning of the enum. The only thing you can assign to, well, you can assign to any of them, but I'd like to start at 0 and work my way up. So it's ball, brick, paddle, ball. There we go. Much better. It should be collision tab, X, Y. These should each be on their own line, but let's ignore that for now. Sorry, we are running out of time. Friend, collided, collidable, boom. Collision checker, boom. Collision checker, yes, boom. Each of these things are in the nothing namespace, right? Because they don't really form any part of any namespace or subsystem. Got a collision checker doesn't care about types. All it knows is I've got these like axis aligned bounding boxes, and I now have to kind of like figure out what they're touching. That's it. So now your simulation says, hey, I've got all these concrete instances of these things, and that should work. Paddle, I know they get like a 50 million things now. You don't need to instantiate those now. Like these don't need special things. The moment you declare, they're auto constructed for you. So that's nice. Paddle. Let's just Control H player with paddle and replace all. Let's see. Paddle dot this, paddle dot that, and wall. Again, new wall. Can I now say I've got a new array of wall? Because they don't take a type. So can I say wall, walls, num walls? Looks like I can. So I can also say brick, somewhat bricks, right? So for my num bricks, I'll just have some number of, oh shoot, that number changes as you go through this. No, that number doesn't change. There's a set number of bricks, right? Let's just say there are 200 bricks, so hash define bricks, let's say 200. So now bricks work the same way. So you say bricks star bricks num bricks, and they don't take anything special. Now I got a bunch of walls, got a bunch of bricks, got a paddle and a ball. Walls are constructed. I believe walls are constructed, so walls 0 is all just dot. Can I say no? Let's just do the easy way. Let's just do that. I can't think of an easy way to like find replace unless you do regex on like bracket arrow alphanumeric. No, bracket arrow alpha. No, it would be wall. Whatever, doesn't matter. Again, this is walls I dot x dot y. It's fine, I will spend this time. This is my personal punishment towards myself for getting it wrong the first time. Right, so does this work? Do you have to go into each one and say equals new? No. It's just an array. It's like they construct as you define the space for it. They construct. It should just give me like the same square. Yeah, it should give me the same thing. So physically, nothing's changed after like an hour of cleanup. But realistically, if you look at it, our entities now inherit you can compose ball. It can inherit from multiple things now because you got a well-defined ball class. You got a well-defined collidable collisions type that just takes this predefined type. We can extend these types. We can extend that system. It's custom built for the solution. It's not an external system. It's part of this, so you can extend it. But now you can define like multiple walls, like little platforms, and say, hey, these are of type wall. Nothing happens when you bounce on them, but the ball can bounce against them, right? So you can now define all these things. You can also say ball now extends from some other class or inherits from some other class, and then add those little like whatever special things those classes need. the collisions framework. I'm going to do some magic here. I think next video I'll teach you how to cheat to get this to work from here, right? The idea would be that you say hash include collision checker.h, and then you'd say collision checker. You would say static collision checker star call. Actually, that doesn't take any arguments. It would just be callman, right? And you just say callman.add this. That's it. That's how that works. So now nothing else can actually access this callman. This thing, Collidable, knows there's a callman. It knows exactly how to deal with it on its own, but no one else can access this thing. No one can fiddle with the source file, so to speak. So this thing is just kind of there. But now the question is, how the heck do you say check those collisions from here? You'd need to put this somewhere else and then pass it into here. So there's like this whole complex method that we're gonna get into that gives us a singleton manager kind of class. It also gets us this kind of thing of saying, you know, get me the call man, and then you can then register, because you know what collision manager interface looks like on this side. You can just include this thing and say, I know what a collision checker does. I can say call man add collidable, but I can go fetch the single instance of it from somewhere else. But this is a cheat. If you didn't need to call man check collisions from somewhere else, and this thing kind of just did its own thing, this is how you do it. But this is not how this is going to work. We're going to add a special collision, not a collision thing. It's like a singleton class that you register these singletons with it, and it just does a construct manage, and then you'd say get me this thing of this type, and it would get this thing of this type, and you'd say add me. You'd know what this interface looks like because you're getting something back of that type. So we'll do that next video, and then hopefully maybe if there's time left, we'll get these balls and paddles and things to move. So I'm super happy because we've now cleaned this up. It now matches 1-to-1 with the mental load of it matches 1-to-1. I think this should still all work the same way. I shouldn't have any weird errors or issues with it. So again, sorry about this. You got again a video where the end result is just the same, or the same as what it was, but the mental strain of using the code base is now eliminated. So I'll go and commit this, push that, and I'm happy. Thanks everyone. Let me just get my awesome stars up as a way to end the video, and then I'll call it. I'll say cheers.